make themselves. Cheers.
All right, guys. So let's proceed. Let's proceed. Right. Cool. So we had basically just worked out this table that we have over here. Okay. And now the good part about actually doing it ourselves is we've come to learn how best to go about it for ourselves. Okay. Right. We obviously know these are the totals, so we obviously need to add each and every one of the columns in order to arrive at the totals in bold. Right. So the next thing is to actually calculate this correlation coefficient. And this shouldn't be too much trouble because obviously it's just inserting the values. Okay. So if we look, the only one that we don't have there is n, and we know n is the number of variables, which is 6. Yes. Thank you very much. We have 6 data points, so that is 6. So now writing out our formula there, we are saying 6, and then the sum of x and y, right, we know is this 1, 1, 0, 3, 3, 1, 3, 5. Okay, then what else do we know? Minus the sum of x is 10, 360 times the sum of y, which we know is 5887. Okay, and then divided by, it's getting more interesting, the square root of 6, the sum of x squared, which is 19639600 minus the sum of x, and then we're squaring that. Okay, so the sum of x is the 10, 360, and then we're squaring that, and then we close brackets, and then we reopen brackets. We say 6, sum of y squared, which is 6,220, 7,997. Okay, minus x, the sum of x, sorry, the sum of y, 5887 squared. Okay, so I want you guys to work that out and arrive at our coefficient, correlation coefficient. I'll give you guys, let's say, 3 minutes. So at 14:14, we will then proceed. What I did. Are we winning? I usually like to calculate stuff, calculate out the brackets, and then do my minusing and so forth. I don't try to do everything in one go, is what I'm basically saying. Yeah, they are. You guys know how to also store on your calculators? Why? Why not? You got it. What's your answer? 0.9983. You put everything. Hey, okay. Are you winning? The 11 what? This one here. Oh, so we added all these. Initially, before I had actually times. No, we're not supposed to time. Yeah. Is it coming together? Should we do it together? So 6 times this 11,033,135, what do you get? So we're not going to literally do it the long way, but it's almost, you're almost sure of getting the right answer this way. What do you get for this first portion here?
Million.
66, just 66 million.
198.
98.
81.
80. Oh, sorry. Okay, so 198 and then? Okay, right. We've got that value. Then here, when you times these two, the 10,360 times the 5,887, what do we get? 60 million. Okay. Somebody else try that. Let's see, are we all getting 60 million? 989, 320. Okay. Right. So then we can quickly minus those two numbers from each other. It depends on your calculator. Yeah, we can. All those letters. It definitely helps. So what do we get? Is it every man for himself again? This is definitely the right answer, by the way.
She has an answer.
Hmm.
Oh, man. Why would you do that? She's not going to say that loud.
Oh, the amount here. Mm-hmm. So you said 5 million?
209,490.
Mm-hmm. 490. Okay. Happiness there. So basically we can cancel this out. And we can cancel that out. Okay, so now we can go to the bottom. Yes?
How many marks is this?
I am actually not sure.
Because if
But this, yeah.
6, 7 marks, then you can go
Then you can go through?
through this week.
Yeah. If it's not, then no. But you see, and there is a way of just punching all this stuff into your calculator and getting the coefficient and stuff like that. There's a YouTube video, because remember we have different calculators. So, but the thing is, if you get it wrong, that's where now, for lack of a better term, you're screwed, because you lose all the method marks and you obviously don't have the right answer. If you get the right answer, no problems. I'll give you all your marks, even though I don't see method, your method. Does that make sense? So that's the only thing you need to be mindful of. But we'll see when we look at a few past tests. We'll see how many marks typically this would go for. I can envision that they'll definitely ask something of this nature, because I see they also ask the same question in revision exercise 1 and also revision exercise 3 and 5, if I'm not mistaken. No, revision exercise 5, not revision exercise 3. Yeah. Okay, so if you do your workings, you should arrive at the same number. In the interest of time, maybe let us just proceed. Okay, but you should get to that. Now the question is, what does this mean? This 0.998 in your textbooks or in your workbooks, they've just rounded it off to 3 decimal places. What does this mean? Your correlation coefficient.
It is extremely strong.
What is extremely strong? The data. You're trading on it. The relationship?
The relationship between the infinite, the distance, and
100%. Okay, so remember, when we are calculating the correlation coefficient, we are asking ourselves, how strong is the relationship between the dependent variable and the independent variable? Okay, and remember, the relationship ranges from what to what? From a -1 to a +1. So if we have a -1, the relationship is still strong. Or if this was a -0.998, it would still be a very strong relationship. But all that it means is that airfares and the distance of your flight move in opposite directions. So basically, we would be actually saying that there's an inverse linear relationship. Okay? So, in other words, as the distance for our flights increase, the price of our tickets decrease. Does that make sense? If this was negative, if this was negative. But because it's positive, we're actually saying they move in the same direction. So we're saying as the distance for our flights increases, so does the price for our flights increase. Okay, so very, very, very much correct there. It shows a very strong linear relationship. Okay, right. So the next thing they ask is for us to determine the coefficient of determination. Now, the coefficient of determination is easy. This is R, right? Now, your coefficient of determination is basically just R squared. So basically, you just need to square this and then times by 100 to make it a percentage. Okay? So let's quickly square this. 0.9983 squared gives us what? What do we get? And then after that, just times by 100. What do we get? Nathan, what do we get? You get 99.66%. Okay, I think if you check in your textbooks, they have it as 99.67. Okay, but that's fine. We can work with this. So ultimately, what is this now telling us? This coefficient of determination, what is it telling us? How do we interpret that? Strong what? Association. Okay, yes. Elaborate. And I'm asking the class at large. Because remember, you guys, it's not only that you must calculate these things, you must be able to tell us, okay, what is the information telling us? Remember, stats is all about, okay, we've got the data, we've analyzed the data. What is the data telling us now? So she said strong association, which is correct, but there's more to it than that. There's more that we can actually share in relation to that. Coefficient of determination. Let's chat GPT, let's Google. What does it tell us? Did you guys have class before lunch? What class? It says what? Huh? Wow, wow. So your coefficient of determination, it lets us know how much of your y variable is explainable by your x variable. So we can say the distance can account for 99.66 of the change in your airfare price. Does that make sense? Okay, so it's, as she was saying, it's a very strong association. All right? Okay. Cool. All right. So that is your fifth question there. Then the last thing they're asking us to do there, and I'm just zooming in, is to now estimate the airfare for a 2,400 kilometer flight. The linear regression equation is used to estimate the airfare. Okay, and we've seen this before. Y is obviously our, remember if we look at our, it's our dependent actually. All right, and remember it's our airfare. We want to predict, remember we said we want to predict our Y. Okay, how do we do that? By obviously having our X values, okay, which in this case we're saying is 2,400, okay, because we want to predict, okay, what then would be your Y value? What would then be the cost of our airfare if the distance is 2,400, okay? Now, if we look at our line, the only thing we have right now is the 2,400. What is B and A in the equation? Sorry? Okay, so your A is your intercept. In other words, if we go back to the graph, it'll be the point at which X is equals to 0. Okay, the value where X is equals to 0. What is the value of that on your Y? Y. X is 2,400. Because we're saying the distance, remember, X is 2,000. Sorry, I mean to say, remember, X is the kilometers of how long your flight is, or the distance of your flight. Okay. Now, all I was trying to illustrate was the intercept. Remember, the intercept is where your X value is equals to 0 on the graph. What is then your Y? Okay. In this case, and I can't trust my graph because my graph, remember, I'm just doing it freehand. But here it's going to be 0. Your Y value is going to be 0 because can you see both X, or actually no, it's going to end up being a negative amount actually. Because we'd have to go further. We want this to be 0. Okay, so it would be a negative amount. Okay. Sorry. But that was just to explain what A is in the equation. A is your intercept. B is what? Somebody want to guess? And this is a recap. I know it's a recap for you guys. Somebody was saying this is math lit, which is very true. We just touch it and go in maths. It's too shallow. It's too easy.
So this was like, it's one of the easiest parts of math.
One of the easier. That's what I'm saying. It was just touch and go. We just. So what was B? No, I'm asking everybody. I'm not just asking you. So B is your gradient. It's this. It's the slope of the line. Okay? I'm sure some of you are, oh yes, I remember. I'm sure. Okay? So now the thing is, in order for us to predict Y, we need to find out what A and B is. Because we only have X, which we have said is the distance of 2,400. Are you still with me? Are we still together? Okay, I was just explaining what those variables are, isn't it? But now we need to establish, okay, what is A and what is B? What is the actual value? Okay. Yes, B is the gradient. It's the slope of the regression line. Here you can see they say B is the slope of the regression line. And A is the y-intercept. Okay. In this case, yes, it is positive actually. Because remember, the line is sloping to the right, 100%. Okay. So here is your formula to calculate that. You can use this formula. There's another formula. Remember, we give you these formulas. We give you. So you just need to plug in the amounts. 3, 4, 5. So this is there. This is there. This is 4. Mm-hmm. This is the beginning of what? This is the beginning of what? So now we need to insert all those values. There's the other way of calculating this, which I think is more, it's the same formula, just a different way. Somebody is saying, sir. Yes? I'm just double checking here before I write this down. So it's the same as this. This is the same. You can use this formula as well. Over n minus okay. So again, we're going back to that table that we had over here and using that. Can we take a quick picture of that and share it on the group so that we can go back to our formula and fill in the values? Everybody is a part of the group, ne? The WhatsApp group now. Okay. Okay, right. So now let's quickly calculate these things. Okay, maybe in the interest of time, I'll just quickly provide the values. So 6 times the 110333135. And guys, you need to practice these things because sometimes it's not that students can't see that this is the formula I need to apply. It's just when they start to apply it, they apply it the wrong way. It's like as though they're touching the calculator for the first time, and then mistakes happen as a result thereof. So please do yourself a favor and make sure. One of the things I like to encourage my students to do is everything that we do in a specific week, make sure that you understand it going into the next week. So that as we build on top of that, you're not already behind because you don't have a good understanding of the fundamentals. What do we get? Remember, I advise just remove the brackets, calculate the stuff separately, and then you got 0,49. 0.49558. Mm-hmm. Mm-hmm. 8. Okay. All right, so that is what they are also getting over here. So this is now our slope. Okay. So basically, what does this tell us? This slope. If we look at the gradient here, if we look at the line, right, what does this tell us? If we say B is the slope of the line, what is it telling us? For every 1 unit increase in our distance, every 1 unit increase in our distance, or 1 unit change in our distance, there's going to be a 0. What did we calculate? 0.4958 increase in your dependent variable. All right? Or 0.4958 change in your dependent variable. So for every 1 unit increase in the x variable, the independent variable, there's going to be a 0.4958 change in the y variable. Okay, reason why I've changed from saying increase is because remember, it might be a 1 unit decrease, which means that the y variable is going to change, also decreasing. Does that make sense? Okay. Right, so then the next step is then to calculate the intercept. So in other words, the value of y when x is equals to 0. Okay, so here all you simply do is we get the total of y. Let me use a different color here. So what is the total of y according to the table provided? It should be 5, 8, 8, 7, and then minus 0.4958. And we said x is what? Well, the sum of x. Okay, I was ambitious in trying to put that all there. Let me move this here. Give myself some space. Okay, that's all we need. So that is 5, 8, and then we are saying times the sum of x, which is 10, 360. Okay, then divided by n, the number of values, which is 6, as was highlighted earlier. So what is our intercept? What is a equal to? Are you enjoying storing your values there? Is it helping? Oh, okay. But I'm sure that calculator can do it as well. I don't use a Casio, so I don't know how you do it there, but it should work. You're getting 126. Anybody else? Are you sure? Okay, so here they're getting 0.09. Okay, so now that we have A and we have B, we can now work out the value of y. Can you see we have all the values on the right side of your linear regression equation? So we simply say, okay, y, when we have a distance of 2,400 kilometers to fly, is then going to be 125.09 plus the gradient, we know it to be 0.4958 times 2,400. What is our predicted cost of the airfare? What is the predicted cost of our airfare? Are you okay? Why aren't you calculating? Yes, I want the answer. 1315,0 1. Okay, so this is obviously in rands, right? Or did we do this in dollars? Doesn't say. Okay, but that's fine. It says rands. Okay, thank you for that. So that's our prediction. Okay. That's our prediction. Now, would you say this prediction is reliable? And this is now you know who was listening when I was presenting on the theory of this. Should I put you out your misery? It's not reliable. Why is it not reliable? Because this 2,400 is outside of the data points that we have been given. We extrapolated it, right? I don't know if I said that right, but something like that. Okay, so you'll see in I think it might be revision exercise 5. They'll ask you a similar question: is this estimation reliable? And you'll get the exact same answer. It's not reliable because it was extrapolated. Okay, right. So is it now making more sense what we have been doing or what we were doing when we introduced the unit? What regression analysis or linear regression is all about? We're looking to assess, is there a relationship between a dependent variable and an independent variable? How strong is the relationship? Correlation coefficient. How much of the independent variable is explained in the dependent variable? That's your coefficient of determination, okay? And then obviously now we need to find a way of predicting roughly, because this is all about estimating. It's not going to give us the concise answer, because if we look at our graph, it's also not 100% concise. That's why we call it the line of best fit, just so we can get a trend or a feel okay, yes. If the flight distance increases, then our price will also increase. By how much? Okay, the slope is 0.4958, I think it was. Okay, so it's just to give us some sort of feel for the data that we are obviously analyzing. Okay, right. How are you guys feeling? It's coming, right? It's gonna take time. Hey, it's not an overnight thing, guys. Don't worry. It's not an overnight thing. I think the biggest challenge here is getting this table right. Once you've got this table right, remember they give you the formulas. Then just knowing which formula you need, right? Because obviously here I laid out the formulas as we went along. But in the test or exam, you'll just have the formulas there. You will need to know which one is your correlation coefficient, coefficient of determination, and so forth, so forth. Does that make sense?
Yes.
Yeah. Then you'll be fine. We can go on, ne? Next exercise. Or you want a break? The next exercise was theory, so I thought we'd just go over that and it's goodbye. Speak freely, guys. It's me. It's me. Don't be shy. Should we quickly just go over? Let's just quickly go over revision exercise 3. It's literally theory. I'll talk you guys through this one. Right? Is that fine? Just give me 10 minutes and 3 o'clock. Goodbye. Right. So here, revision exercise theory. Here they say below is a scatter diagram illustrating the number of bottles of cool drinks purchased according to the number of family members. Okay? And then it says the sample families were selected from customers who visited the Lit Superstore during a specific day. Okay? What was the sample size? Now, for you to calculate that, you simply just calculate how many people actually participated in the survey. Okay, so you quickly calculate how many how many people did, and you just count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So it's the sample size is 13. Okay, then do you expect a positive or negative relationship between the two variables? You guys tell me, do you think this is a positive or negative relationship between the family size and the number of bottles purchased? Positive. Why do you say positive? Yes, it is sloping to the right, like we saw with our other graph, isn't? So this is definitely a positive relationship. Then we go on and says, what is the smallest value reported for family size? Smallest value. We know that the family size is on the x gradient, isn't it? Sorry, the x-axis. What's the smallest value reported? It's 1. Okay, it's 1. Okay, everybody happy with that? Last question. What is the largest value reported for number of bottles of cool drinks purchased? Largest number. It's 5, ne? It's 5, because here we're looking at the y-axis. Everybody happy with that? So last one is 5. And we're done with some extra time even. Okay. So if someone can just help me here with the register, I will then see you tomorrow. For homework, I'll ask, please, can you do revision exercise 5? If you you can do revision exercise 5 for tomorrow, and then we'll go over it together.